Hello. Good evening, everyone. Is it visible? I have
Good
shared the
evening,
screen.
sir.
I have shared the screen. Is it visible right now? If it is visible, then we'll go for that. Okay. I hope it is visible. Can anyone confirm it? Yes. Be able to see the PPT. Hello.
No, sir.
Not able to see the PPT. Live.
No, sir.
Now. Whether it is visible now.
Yes, now visible.
Okay, fine. Fine. So my name is Abhishek Munshi. I'm a PMRF research scholar at IIT Jodhpur. I'm working at Transportation Electrification Lab. And so today we're going to discuss about the electrical machines, some doubts and some questions which are related to the assignment of this week. I hope you already learned the this week lectures and the last week lectures, right? Have you gone through the lectures? Promote.
Your voice is very low, sir.
So now can you able to hear me? So
Yes, sir, but slow.
low, low or low? Fine. Uh,
Yes.
Let me check whether there's any problem from this side. Hmm, fine. Okay, fine. So in this week, you've already gone through the lectures like magnetic circuits and transformer, right? So we will discuss a little bit about these things, and then we'll move into solving some problems which will be help you to solve the assignment of this week. So, so mainly we will cover the magnetic circuit and transformer a little bit. So moving into the problems, I will discuss a little bit about the fundamental laws which are required for doing the electrical machine to going on with that. So So basically, electrical machines, this course is based on electrical machine one. So here we will learn about the moving machines and static machines. In under the static machine, there is the transformer and the machine which are based on magnetic rotation, RMF, and all that are going to be learned in the next few weeks. And that will be DC machines, synchronous machine, and induction motors. Okay. So for all type of machines, you have to know the basic fundamental of some magnetic theory. So based on which you can see that on the slide that you have to know a little bit about magnetic field. So if there is any magnet, then we can assume that around which there will be a field, right? So in our when we are not able to know about these things, magnetic field and all, we used to do to we take two magnets, and when they come close to each other, then they will attract or repel each other, right? So if you can see that if you remember those days that whenever we were to play with the magnets, that there will be a region and out of which the magnet will not attract or repel, right? So that region is called the magnetic field region. So if you see in this picture that around a magnet there will be some lines of force. Okay. So basically these lines of force flowing from north to south outside the magnetic field, and in inside it will flow from south to north in direction. Right. So these curved line are the visual representation of the magnetic field. Okay. So this was basically given by Michael Faraday in uh, previously. So basically magnetic laws are based on two theory. One is whenever it has opposite poles, it will attract each other, and whenever it has similar pole, it will repel each other. This is the basic fundamental of a magnetic theory, right? Next thing we have to know about is magnetic flux. So what is magnetic flux? Basically, the amount of magnetic field that is produced by a magnetic source is called the magnetic flux. So its unit is Weber. Okay. And flux density, we know that density means basically if what is density? Density, mass per unit volume. So here in this case, if magnetic flux density means the flux present per unit area. Okay. So this is magnetic flux density. The unit of which is Tesla. So 1 Tesla is equivalent to Weber per meter square. Okay. So these are the fundamental things. I'm just revising you so that you are able to know the fundamental things to do the problems of machines. Okay. Next is that the magnetic field due to an electric current. So whenever there is an electric current flowing through, and there will be the production of magnetic field and vice versa. Whenever there is a magnetic field, then it will also produce an electric uh, current, that is electromagnetic theory based on which, right? So this theory, if we know that, then you can see that there are a lot of rules we can follow. Number one is Maxwell force Q rule. So here, if you see that, then if this is the direction of the current, then the moving direction of the screw will produce the magnetic field. Fine. And very easy to understand by the right hand thumb rule. We officially mostly we use right hand thumb rule. In right hand thumb rule, what happens if thumb is our current direction, then this will produce the direction of magnetic field. If our thumb is downward, then in that way. If the thumb is upward, then in that way. Okay. So this is what we have to know, that whenever there is a current is flowing, then a magnetic field will definitely produce. And to understand the direction of the magnetic field, we have to know either corkscrew rule or either right hand thumb rule. So it is very easy to understand the right hand thumb rule. So I will prefer to do problems through right hand thumb rule. Okay. Till now, any doubt? I'm just revising the basic things so that you can able to understand the transformer problems. So if you have any doubt till this slide, you can ask me.
No doubt, sir.
Okay. Next thing is that Ampere's circuital law. In Ampere's circuital law, you can see that the law states that the line integral of tangential component of magnetic field intensity around a closed contour is equal to the total current linked by the contour. So if you consider that this is a contour, fine, and we have suppose I1 current going inside, I2 current going outside. Okay. So it states that the total current will here I1 minus I2, since one is in the this direction, outward direction, one is in inward direction, right? So it states that the line integral of magnetic field intensity is equal to the total current inside it. So in this case, which is I1 minus I2. If a problem comes in that way, that there is a closed contour is given and you have a numerous current going out and in, asked to calculate the uh, magnetic field intensity, then you have to solve it in that way. That you have to know the area, either the length. If we solve that, then we'll get HL is equal to I. That is the total current going inside or outside that contour. Okay. The next thing is that this is the fundamental law behind every electrical machine, that is Faraday's law. So you should have to know Faraday's law before moving into electrical machines. Okay. I hope you have a assignment on the first week zero. And on that case, you're on that assignment, I think this type of problems may come. So, Faraday's law states that whenever there is a varying magnetic field, it will produce a electric field. And the vice versa is also correct that whenever there is a varying electric field, it will produce a magnetic field. Fine. So it states that a voltage which is induced in the turn of a wire is directly proportional to the change in flux. The rate of change of flux change is proportional with that. That is proportional to d phi of dt. Fine. So if we have the number of turns increased from 1 to n, then we can modify the law into E equal to n d phi dt. Fine. But we're using a negative sign here because of the Lentz's law. You all are electrical engineer. I think you all know the Faraday's law and Lentz's law. But I also write it over here that the negative sign is due to the Lentz's law, which states that the induced EMF here is obviously opposes the cause of the induction. Fine. And based on which we have two laws. You can have to know these things the more in case of DC machine. That is Fleming's right hand rule and Fleming's left hand rule. Okay. This is left right hand rule and this is the left hand rule. So it states that if our three fingers, thumb, first finger and middle finger, if they are in 90-degree perpendicular to each other, then if our thumb will represent the force, then this first finger will produce the magnetic field, then obviously the middle finger will denotes the direction of the current. And the vice versa in case of the right hand rule is also applicable. Well, fine. So these are the basic laws you have to know before going into electrical machines. So if you have any doubt, you can ask and we will straight move forward into the problem solving session. Okay. I will give 5 to 6 minutes for each problem to solve. Try to uh, interfere in these things and try to solve and answer in the comment box. And you can comment also by voice. So it will help you all to practice the session so that you can able to solve the assignments of this week. Right. So try to solve the problems which I going to given over here. Uh, I will give 2 5 minutes based on the problem uh, difficulty, but please try to solve by your own before I solve it. If you're not able to solve it, then try to learn it. How can we can solve that? But please try to solve so that you can able to learn these things. Fine. Otherwise, there is no issue of doing this type of discussion classes. Okay. So, so this is a problem. So I'm giving 3 4 minutes to everyone to solve it, and after which I will solve it. Okay. So this is the problem. Try to solve it. Everyone try to solve and participate so that you can able to understand. Okay. I'm giving 5 minutes to solve it. Yes, Ashutosh. Yes, Ashutosh, you raised your hand. If you have any query, you can ask. You can write it in the comment box. Okay.
Option D is correct.
Okay, fine. You know these things very well. So try to give others also participate over here so that they can able to answer. After 2 minutes, I will check. If it is better, you can write it in the comment box so that other can also participate and solve it. Okay. I'm giving two
Sir,
minutes.
option D is correct, sir.
Okay, okay. Don't you have to say by one. So just write it in the comment box. And those who are not able to solve it, then don't get panicked. I will solve it. Just go through the laws which I state. I'm giving 2 minutes because I think most of you have done it. I'm giving 2 minutes to solve it. Okay. Yes, Ashutosh. And most of you have answered this correctly. That is option D. So, who solved it first? Bhupati. Can you explain it? Ashutosh, can you explain it? Why option D is correct? Yes, Bhupati.
Sir, because according to thumb rule, if the
Yes.
current is flowing upwards, then we can see that the direction of flux is in here
In this,
anti-clockwise.
right. If current is going in this way, then if we move around like this, right? So it is
Yes, sir.
absolutely correct. So everyone has answered it correctly. So I hope you have the basic fundamental clear of the kinetics. So now moving into the magnetomotive force. Uh, so basically, in case of any electrical circuit, we see that current is produced. That is due to the EMF. That is due to electromotive force. Fine. Similarly, in case of a magnetic circuit, MMF is produced due to the magnetic flux. So we can, from the analogy, you can say that the current is similar with respect to the magnetic flux. Fine. So if we have n number of turns, then the MMF should be n into I. If we have a one turn, then that will be equal to I. If we have n number of turns, that is equal to n into I. Fine. So if you're going through an analogy of a magnetic circuit with electrical circuit, you can see that in magnetic circuit, the driving force is MMF. In electrical circuit, it is EMF, right? So in case of electrical circuit, it is EMF. In case of magnetic circuit, it is MMF. And current is analogous to the magnetic flux. Fine. And in case of electric circuit, we see that we have R, that is resistance. Fine. So according to Ohm's law, that is V equal to IR. In case of magnetic circuit, the analogous to the resistance is denoted by this sign, that is reluctance. Okay. that is reluctance. So this is the analogous between the magnetic circuit and an electrical circuit. So why we need to know this thing, that MMF? Because the agenda of our learning today is to do the problem solve of transformer. So basically, in case of transformer, if you see that there is a primary and secondary winding, but there is no linkage, physical linkage in between of that, then how could it helps to flow from primary to secondary side? By means of magnetic circuit. Okay. So there also due to the electromagnetic field theory, from primary the current is induced in the secondary, the flux is induced in the secondary, and that's why we will get a voltage accordingly at the secondary side. Right. So transformer, whenever we will solve problems, that mostly in practical transformer. But what is an ideal transformer? Basically, in case of an ideal transformer, we are negliging the winding resistance. There are no winding resistance, and we assume that all the fluxes are confined to the core and linked to the both windings, and there is no leakage flux. But in practical, if you see that when from primary is flowing from the secondary, when the flux is flowing from primary to secondary, there should be some kind of leakage flux over there. Okay, that's and due to which we are determining that the coupling coefficient between the primary and secondary will not be always one. That will be a little bit lesser than one. Okay, so that is a major factor when uh, magnetic flux is flowing from one field, one side to another side. Okay, so but in case of an ideal transformer, we consider that the leakage flux should be zero. Right? There should be no leakage flux. Another thing is that the permeability of the core is infinite. That's why we can say that the exciting current, whenever the flux is flowing through a primary side coils, we can say that whenever a flux is flowing from this winding, a flux is induced, right? So the exciting current required to establishing the flux in the core is basically negligible, since we have permeability is infinite. Right? So this is the basic laws and formulas I will discuss, and then I will solve some numericals. So try to put the formulas in your copy. If you have a copy, rough copy, then put the formulas so that you can able to solve the problems. When I give you 2, 3 minutes or 5 minutes to solve one problem, then you can participate over there. So for that reason, you need to note down the formulas. And if you already note it down from the lectures of this week, then it's all right. Okay. So if we have a primary winding connected to a time varying voltage, suppose V, then obviously a time varying flux is established in the core, and due to which a voltage E will be induced in the winding. Fine. So you can say that V1 E1, that is equal to N d phi dt according to the Faraday's law, which I discussed. This is from the Faraday's law. We can state that this EMF should be equal to the rate of change of flux with the number of turns. So if we have n1 number of turns at primary, then you can say that at primary side of the transformer, the voltage induced is n1 d phi dt. Similarly, in case of the secondary, when this flux will link into the secondary side, a secondary current will produce. And on that case, whenever that current is flowing from that, you can also applying Faraday's law on the secondary side and say that EMF or the voltage induced as secondary is N2 d phi dt. Fine. And from these two, we can write N2 d phi dt by N1 d phi dt, that is equal to V1 by V2, sorry, V2 by V1, and d phi dt cuts out, and it will be V1 by V2 is equal to N1 by N2, right? So this is the basic formula of a transformer, that if we have a primary winding of N1 and secondary winding N2, then the voltage induced and the voltage developed over primary side by voltage in the secondary side is equal to N1 by N2. Okay, we called it A or K In some book, you will find that it will denote by A. In some book, you will find that it will denote by K. It's the turns ratio. Fine. So can anyone say that what will be I1 by I2 then? If V1 by V2 is N1 by N2, then I1 by I2 will also be N1 by N2 or not?
No. N2 by N1.
Why?
No, N2 by N1.
Can anyone explain it? Why?
Yes, due to MMF balancing, N1 I1 equal to N2 I2.
Ah, absolutely correct. Who said that? What is your name? See that.
Pramod Kumar.
Ah, problem. Very active in this case. Why? So this is definitely a correct answer that due to the MMF balance. I hope Pramod had gone through all the lectures and one girl also said the answer. I didn't recognize his name. So you, I think those who gone through the lectures can able to understand these things, right? So this will be 1 by A. So Pramod, are you doing BTech? Are you a BTech student or MTech student? Hello. Right. Okay. Now rotate down in your copy that we will solve some problem with this formula that you can see in case of a no load test of a transformer, whenever there is no load across the transformer. In transformer, we do two tests. One is short circuit test, another one is open circuit test. That is no load test or load test. Fine. So know the losses inside the transformer, whether you have to calculate the core loss or copper loss depending upon it. Okay. So whenever it is in no load, you can say that if we have maximum magnetic flux by density around 5 max, then you can say that the rated voltage that will produce under the no load current I naught, suppose I naught is the no load current flowing through it, then obviously there will be a voltage developed, and that rated voltage should equal to root 2 pi pi max f into n, where f is the frequency, the line frequency, basically it is 50 or 60 hertz, and n is the number of turns, and phi max is the maximum flux density, and this is root 2 pi is the constant. Okay, we'll see. So this is the formula. I have to know that in case of a no load, what will be the maximum flux. You can it can be asked in the assignment. Okay, so in this week assignment, I hope a problem is coming in this formula. So I'm giving a problem this way. So try to solve it. I'm giving 5 minutes, and for 5 minutes, please write. If you have already solved within the 5 minutes, then please comment it there and don't say it loudly so that everyone can participate. After which, we will definitely solve it. And if all of you have done so able to solve it, then I will discuss it with you all. Okay. So try to be interactive, and then it will be fine. So I'm giving 5 minutes to solve this. So try to solve it and post it in the comment. Okay. Fine. Many of you have solved it, right? So, so let me solve it for those who have not able to solve it. So I said that the formula is the rated voltage is root 2 pi pi max F into N. Fine. So in this case, a transformer is same. So that's why we have pi max N is same. So in first case, we have F1 equal to 50 hertz. On that case, you can write V1 equal to root 2 pi max 50 into N, N1, right? In case of F2, when it is loaded with 60 hertz, fine. First, it's loaded in 60 hertz, and then it is in 50 hertz. So it is 50 hertz, and V2 is equal to root 2 pi max 50 into N. So here N1 is equal, N2 equal to N. So V1 by V2 will be, if we cut it out, it will be 6 by 5. So V2 will be V1 into 5 by 6. So our voltage is only differed 5 by 6 times. So kVA will be also 5 by 6 times. So the kVA2 will be 12 into 5 by 6, that is 10 kVA. So those who have got the answer 10 kVA, absolutely right. Many of you have solved it. Fine. Is it clear? Anyone have any doubt? If you have any doubt, you can ask. Because the next problem is also based on this formula. If you're able to understand this, then you can able to solve the next problem.
Why multiply, sir, this?
I didn't understand what you're saying.
Why
Can you
multiply 5 by 6 in 12?
see? It is given here that the 12 kVA is for the 60 hertz. So V1 should be 12 kVA. For the first transformer, the kVA is 12. So you are asked to calculate what will be the kVA of the second transformer. So if the voltage is 5 by 6 times, then the kVA will also 5 by 6 times. So if in the first case, if you have 12 kVA, then in second case also 12 into 5 by 6 times, that is 10 kVA. And how I getting 5 by 6 times? You can see that V1 by V2. We're just comparing it with, and everything cuts out, only 60 by 50 difference. Because the frequency is only different, the transformer is same, right? Is it clear?
Okay, sir.
Right. So I'm giving a similar problem. So this time I hope everyone will able to solve it. Calculate the phi max when a transformer having 100 turns and frequency is 50 hertz and RMS voltage is 105 10 volt. Okay. So try to estimate the peak value of the flux, that is phi max. Okay. I hope those who have not able to solve the first one can able to solve it right now. Okay. So I'm giving 3-4 minutes to solve it. Many of you have answered it correctly. So this is also the same formula. So we have V rated is root 2 pi max f into n. So pi max should be V by root 2 pi f into n. So V is given 110 root 2 pi 50 into 100. To solve it, will be around, if you calculate it, then it will be around 4.951 milliweber. So those who got the answer 4.951, it's absolutely correct. Okay. So now the next formula, if two transformers are in cascading mode, like this way, suppose our first transformer had a ratio of V1 by V2 uh, connection. Suppose this one is V1, this is V2, voltage here, and here it is V3, V4, fine. And it has a frequency same of F frequency, suppose it will be maybe 50 hertz, 60 hertz. Then you can say that the maximum allowable primary voltage is the minimum of V2, V3. In this case, to calculate the minimum of V2 or V3 into V1 by V2, because that will be reflected in the primary side, the maximum allowable primary voltage. Okay. If you are asked to calculate the supply current, then it is also the minimum of I rated of transformer 2 with the I rated of the primary of transformer 1 into V2 by V1. Okay. Since in case of the current, the trans ratio is reversed, so it is V2 by V1. Okay. And if a resistance RL is connected, then the formula will be to calculate the minimum allowed resistance is V2 by V1 square, V4 by V3 square. It's based on the referred to the primary side concept, and I will discuss it in next problems also. So these are the formulas we need to solve for the next set of problems. Okay, so try to note it down in your copy and move into a problem. Try to note it down. This is the formula to solve the problems when the transformer connected in cascade mode with a similar frequency. So I'm giving a problem related to these formulas, and I'm giving 2-3 minutes to try to note down the formulas. Okay, so that you're able to solve the set of problems. If you're done with it, then I will show the problem. And so this is a problem for the next set of 4 questions. So there is a transformer cascade with another transformer, and those transformer has ratings like this: 480 by 1200 50 Hz 5 kVA, 1000 by 400 50 Hz 5 kVA. The first question is how much is the maximum value of supply voltage that can be connected without exceeding the ratings of any of the transformers. So the formula which I shown can solve it with that. Okay. So I'm given 2-3 minutes to solve it. I hope you all able to solve it. Try to solve it. Please close the video or I have to remove you. Fine. So in this case, I said that the maximum allowable primary voltage is the minimum of V2, V3 into V1 by V2, right? So here we have a transformer 1 with V1 by V2 as V by 1200 and transformer 2 has V3 by V4 as 1000 by 400. Okay. So from here we can see that the maximum allowable primary voltage should be minimum of 1200 thousand into V1 that is 480 by V2 that is 1200. Fine. So the minimum amount of 1200 and 1000 is 1000. To solve it, it is equal to 400, right? So the maximum value of the supply voltage is 400 volt. Fine. So the next question is how much is the maximum value of current?
Sir,
So
sir,
this is the formula. So
hello,
if you don't know that, then please try to note
hello,
it
sir.
down. Yes,
सर कैन यू सर वो पिछला वाला स्क्रीन थोड़ा फिर से दिखाएगा सर.
this one.
No, no, sir. The previous problem, sir.
For solving the previous problem, you should have to write the formula. And if you've gone through the lecture of the last week, then you can able to note it down in one person. Based on this formula, I solved it. I'm showing it. Okay. So after this, try to solve the next problem. So if you're done with the copying, then you can say that. Okay. After copying it, save it.
Sir, how it can 400, sir?
So based on this formula which I shown written over there, that the maximum allowable primary voltage. So for derivations, I'm not able to derive this in this 2 hour class, right? So you have
Okay,
to
sir.
run through the lecture, and I'm showing you the formula so that you can able to solve it properly in the assignments also.
Okay, okay, sir.
I can The derivation is not so big here. So this is V1 and the secondary side is V2. Okay. So the maximum, what will be the primary voltage? You are asked for that. Okay. What will be the primary voltage? So here it is C. So here it is V1 and here it is V2. And this one is V3. So in this common node, we have to take the minimum of this V2 and V3. Okay. And rest is same. You have to calculate it to multiply it with the turns ratio. The turns ratio should be V1 by V2, right? It's a not big deal.
Sir,
Yes.
sir,
Yes.
sir, after, sir, by solving this problem, sir, after it is written minimum 1200 comma 1000 into 480 by 1200. Sir, after that, how
Yes.
it came 400, that one I can't understand, sir.
Is it not coming 400? See, the minimum of 1200 and 1000 is 1000. So 1000 into 480 by 1200. If you calculate it, what will be the answer? 12, 48 divided by 12 is 4. So it is 40 into 10. So it is
Okay.
400, right?
Sir, 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 the mistake is from my side, sir. Sorry, sir.
No, no, no. It's okay. No, no, no. No need to be sorry. Okay. Can you note it down?
Yes, sir.
Yes, sir.
So if you have done it, then I can show the next problem.
Okay, sir.
So this is the next one. So this is also based on the formula which I given over here. If you don't note it down the formula, then try to note down the formula and you can able to solve. So this is the problem number 4. So asked for the maximum value of supply current. Pallapu Raja, can you please stop your mic? Yes, thank you very much. So this is the problem. We have here you have to calculate the maximum value of the supply current. In case of the current, the trans ratio should be inverse of the voltage, right? So solve it. Fine. So, in this case, you have to calculate the maximum supply current for the primary side transformer, right? In here also, for the primary side transformer maximum, you have to take the minimum of IST1 for the secondary side of transformer 1 and IP of T2. Have to take the minimum of these two, and then it will be multiplied by the turns ratio 1 by, that is V2 by V1. So for which we have to calculate the secondary side transformer current, primary current, and this one. So for which we need to know the kVA rating is 5 kV and the voltage is 480, right? So let me copy it. Fine. So what will be the secondary current of transformer 1? That is kVA by the V2. That is 5 kVA by 1200, and IP of T2 is kVA by V3. That is also 5 kVA by 1000. So if you solve it, what will be the answer? Will be in calculator. This one is 5 ampere. This one is 4.16 amp, right? So what will be the maximum allowable current? That is minimum of 4.165 into V2, that is 1200 by 480. The minimum of it is 4.16, 1200 by 480. Solving it, what will be the answer? We solve it.
Sir, I am not able to understand, sir.
So this will be 10.416 amp. Okay. Those who got the answer 10.46 is correct. Who said that? I didn't understand it.
Sir, sir, sir.
Okay. The thing, see that in case of the voltage, we also use this formula that we have to take the minimum in between of the this case. See here, these two are cascaded. So I have to take the minimum current or minimum voltage when I have to calculate the maximum allowable voltage or current. Okay. The minimum in between of this is the secondary side current of the primary transformer 1 and the primary side current of the transformer 2. I have to take the minimum in between of these two currents. So I calculated the secondary side current of transformer 1 and primary side current of transformer 2. And in case of the current, if you're referring it from that to that, then that will be into the turns ratio, 1 by of the turns ratio. So that is minimum current by into V2 by V1. So we calculated these two current and multiply it with the turns 1 by turns ratio. This is basically nothing. This is 1 by A. In the first slide of the transformer, I said that I asked this question. Okay. Is it clear?
Sir, in
Yes, sir.
the formula slide, there is a wrong formula, sir.
Okay, then it is wrong.
सर आपने फॉर्मूले दिए थे ना इसके लिए उसमें
Formula slide, what was that?
सर आई रेटेड ऑफ सेकेंडरी ऑफ T2 लिखा है सर उधर
तो ये गलत है. तो ये P1.
हाँ सर इसीलिए मेरा गलत हो गया.
So this is I-rated primary of P2. See, it depends upon the connection. So in this connection, you're seeing that this is the primary, not this is primary. This is secondary and this is primary. Maybe I put it in wrong way. So just understand it. If you're able to understand, then you don't need to memorize the formula. Okay. So the next question is how much is the maximum value of the kVA? You have to calculate the kVA, maximum kVA, not so maximum kVA that can be transmitted to the load without exceeding the rating. We already have the current and voltage, then what will be the kVA? Solve it. You need to have the diagram here. So what is the diagram? If you have the data here. Now we can able to solve it. Now solve it. See, to solve it, uh, if you see what will be the maximum kVA, that is the, here we have to calculate it, maximum allowable kVA. So for which we have to know the primary side voltage of transformer 1 and primary side current of transformer 1. Okay. But if you see that there is, whenever we are transforming it, this winding is also in between of that. So we have to divide it through N1 of transformer 2. So now we can put the values which we have already calculated. I think this is 400 and this one 10.46. How much it was? 10.416 by 1000. So if you solve it, what will be the answer? This is around 2.5 divided by 2, which will be around 4.156. Is it correct? Now the next question is to calculate the load resistance. To calculate this load resistance, so we have to, I will discuss it in the next slide, that whenever we are referring a resistance or an impedance into the primary side, it will be impedance will be multiply divide by the k square. When referring it into the secondary side, then it will be z into k square. And sometimes the questions come in that way, that we are seeing from the primary side. If you are seeing from the primary side, then that is referring to secondary side. You have to multiply it with k square or a square, whatever, right? This is trans ratio. Okay. So now we can try to calculate RL with the formula which I have given. see in this problem, we have to calculate the resistance RL seen from the supply, right? It means we have to refer first the resistance into here. So if you're converting the resistance from this to this, then we have to, for stage one, this stage one, and then again we have to move it, refer it into this. This is stage two. For first stage, it will be 1 by the turns ratio, that is 400 into RL. Similarly, for stage two, the resistance became this. So it will be 1 by 1200 by 480 square into RL into this one, 1 by. Fine. So ultimately, the referred resistance would be so we have to know the value of RL. So what will be the value of RL? Anything is given over here. So we calculated the primary voltage. So in this case, the equivalent circuit becomes like this. We have the supply and we convert the RL two times, that is RL here, suppose it is RL dash, and then we refer it into here, that RL double dash. So RL double dash, we have to calculate it. But what is the value of RL? Then if you convert it here, then that will be the primary voltage of the transformer 1 by the primary current of the transformer 1. Right? So we calculate it 400, and this is 10.46. So if we know the value of RL, then we can able to calculate the RL double dash. So if we calculate it, it will be around 38.40 ohm. So multiply it with this and tell me the answer. So if we solve it, this is also around 38.40. Fine. So we are just referring the resistance on the primary side. Is it clear? To refer this, we have to know this formula, that if we are shifting, what will be the shifting in impedance in a transformer? So if this is a transformer and we have primary resistance and reactance as R1 and X1 and secondary as R2, X2, the turns ratio is N2 by N1. Then whenever we are referring the transformer resistance to the primary side, that is if we are taking the resistance into this side, then it will definitely 1 by K square into that impedance. Okay. So if you know the value of Rx, can able to calculate impedance. That is Z is equal to root over of R square plus X square. Right. Since from the impedance triangle we know that this is Z, this is R, correct? Fine. So this will be our power factor angle. Similarly, if we are transforming the register into the secondary side, if you refer it, then it will be multiplied by the trans ratio. Okay. So the referred resistance and the reactance should be multiplied with the trans ratio N1 by N2. Okay. So this is the basic formula for shifting a transformer resistance from one side to another side. So based on which I will give three questions on this common data. Okay. So in the above figure, Vs is given. So the supply voltage is given as 250 volt. Trans ratio is given 600 by 150. Reactance is given 12 ohm. RL is given 1 ohm. You have to calculate I. So keep it in your mind that in that case, for the value of primary current, we have to move it into the secondary side. So I have to multiply it with the trans ratio. So try to solve it. If you have any doubt, can ask me. In this case, to calculate the primary current, just take the equivalent diagram of the transformer in which we will see that the resistance, the primary side resistance, that is reactance, which is given, and the resistance are referred to the secondary side. So it will be multiplied with A square. Okay. I am saying that only Pramod is only answering. So rest of you are not answering the questions. Run through the lectures and it will be easy. And try to understand by the problem solving. It will also help you to solve the assignment. Okay. Maybe some of you are preparing for GATE, some of you are doing MTech, some of you are doing BTech. So based on your level of study, you can able to solve it. But if you are understanding these questions, then it will be helpful. some of you have answered it correctly. So here we have to calculate the primary current, that is I, right? So for which, what will be the primary current then? That is our supply voltage by the total impedance. Based on the Ohm's law, it is V equal to IR. So here it is Z. So Vs by Z. So we have to calculate the Z. If we know the value of Vs as 250 volt, we have to calculate the Z only. So for Z, that is equal to x square plus r square. So x is given, r is given, so we can able to solve it. But the trick is behind that. RL is given in the secondary side, so I have to convert it into the primary side. So seeing from that, basically we have to use the formula referring to secondary side. So the RL is given at secondary side, so use the formula referring to secondary side. That is, the RL is equal to k square into RL. RL dash is equal to k square into RL. K is 600 by 150 square into RL. So what will be this?
4.
4 square, right? So 16. So it is 12 square plus 16 square. If you solve it, then what will be the value of Z? 400 root over 400, right? 20. The value of Z is 20. So we put it over here, then it will be 12.5. So those who got the answer 12.5, it's absolutely right. Next part is that we have to calculate I2. This is easy. We have the value of I1, 12.5, and rest of the data are here. So I think I2, what the value of I2 can be calculated by all of you. So I'm giving 2 minutes only. See, I2, the calculation of I2 is very easy, right? So why, I don't understand why all of you not able to answer it. I said that I2 by I1 is N1 by N2. So I2 will be I1 into N1 by N2. 12.5 into 600 by 150. That is 12.5 into 4. That is 50 ampere. Right? The next part is we have to calculate the power. We know power is equal to V into I, but here this is not resistance. Here we have an impedance. So in case of an impedance, we run through the impedance triangle. If this is X, this is R, and this is Z, this is theta angle between X and R will determine the power factor angle. Okay. So if we have an angle, power factor angle in between voltage and current, then the power is VI cos phi. Cos phi is the power factor. So we have V, right? That is the supply current voltage 250. In current we calculated is 12.5. So it is 250 into 12.5 into cos of phi. So just calculate the value of phi. We have Z R X, right? 12, 16, and 20. This is 20, 16, 12. So calculate phi, put it in cos phi, and tell me the answer of power. Yes. Hello.
36 degree.
Degree.
36.
Right. Then what will be the power? So you can calculate in any way. So you know the value of Z R X. You can directly calculate cos phi from here also. Or you can go through like this tan inverse of X by R. This is a basic formula. Right? And then cos of phi is cos of tan inverse of X by R. You can directly calculate it by Z by, sorry, R by Z. R by Z is also the value of cos phi, right? So It will be cos of an inverse of 12 by 16. This 3 by 4. An inverse 3 by 4 cos of 0.8 is 250 into 12.5 into 0.8. We calculated what will be the value, that is 2500 watt. You're asked to answer in watt. Many of you have answered like 2.5 kilowatt. So if you're asked to answer in watt, try to answer in watt. Otherwise, you will get negative marks. Okay, fine. Can you turn off your mic S200264?
నా
Gopal, can you turn off your mic?
కింద వదిలేస్తున్నాయి.
కింద వదలలేదు బకెట్ లో వదిలేస్తున్నా అలా మర్చిపోతున్నా.
Fine. The next question is based on the MMF balance. In this case, there is a primary side, secondary side, and in secondary side, we are saying that this is a secondary winding, another is tertiary winding. Secondary winding is there, tertiary winding is there. So what is the MMF balance? Here, the formula will be I1N1, that is equal to I2N2 plus I3N3. Use this formula, and next, the ratio of voltage that will be induced in secondary, that equal to I2 R2 by R3 R3 equal to N2 by N1. Use this formula and this formula to solve the problem. Okay. I'm giving 5 minutes because you have to solve it.
So I2 by I3 equals to 5 by 4, sir.
Okay, fine. I'm solving it because any of you have been answering. Fine. So from MMM balance, that is 8 into 100, right? Sorry, this is I3, I2. So if we divide it with, we're getting equation number 1. Second equation, I said that I2 R2 by I3 R3 N2 by N1. Put the value R2 is 100, I3 into 50, that is equal to, fine. So we have two equations. So from here you have to solve the problem. Have you solved it? Anyone didn't solve it? Right. So this is I2 100. So from here we are getting that is 2I2 by I3 125 by, oh sorry, this 50, right? We have to take this one into N3, 5 by 2. It's 4 I2 is equal to 5 I3. So I2 equal to 5 by 4 I3. If you solve it, put the value of I2, sorry, I3, anyone. If you can put the value of I2 in equation 1, these are equation 1. We got I2 equal to 5 by 4 I3. So doesn't we get a simplified version of it? Yeah. Just put here. What was the answer? Someone had said the answer. It will be 25 I3 plus 8 I3, 128. That is So I3, we calculate I3, then I2 will be 5 by 4 of this. So how much it will be getting? 3.87. So I2 will be 4.84. So those who got the answer 3.87, 4.84 are correct. Okay. So the next part I put was I3. So we already calculate I3 as 3.87 ampere. Okay. Now we have to calculate the RMS value of the primary voltage. So to calculate the RMS value of the primary voltage, have to know that N1 by N2 into I2 R2. Why I2 R2 is our secondary side Vs, right? Vp by Vs is N1 by N. Since Vp by Vs is N1 by N. You can also write it as V1, this one as V. So we have N1 by N2 and in this case I2 R2 is also equal to I3 R2, right? So that's why we can also calculate it in this way N1 by N3 into I3 R2. So any of the formula you can put because at the secondary side the voltage across each will be same. So if you put the values N1, N2, we need this photo. So if you put the value of N1, N2 in calculator, what will be the answer? It is 387.87 volt. Is it right? Hello? Anyone got this answer? Fine. Next part is what is the power delivered? What will be the power delivered? That is Vp into I1 into cos phi. Since it is resistive load, so phi will be 0 and cos of 0 is 1. So in this case, power is Vp into I1. So we got the value of Vp. Got the value of Vp 387 and I1 is 8 given, right? So if we put the value, it is 3097 watt. Fine. Next question is that what will be the impedance seen by the source? That is Z equal to Vp by IP. Vp is 387.87 and IP is 8. So this will be the answer. If you calculate it, 48.48. Fine. So this is the last set of question. In the last set of question, if you have any doubt, you can ask me. or else the class will be over today. And if you have any doubt, you can ask me. Can you please go through all the pages so that I can take screenshot? Okay, I will share the PPT in the platform, and the video will be uploaded in the YouTube.
Sir,
So you can. Huh?
am I audible?
Yes, yes, sir, audible.
Sir, sir, the voltage of secondary side and test secondary one and tertiary one is equal, sir.
Yes, yes.
Okay, sir.
The video will be uploaded and will share with you, and also the slide will be shared. So no need to worry about it. I will upload it by tomorrow. You can get it through NPTL. And the video link I will, you can scroll through the YouTube channel, and there you can find the videos, previous lectures of others. Okay. So if you don't have any doubt, I can drop the class right now. Any doubt? Question
No,
number
sir.
12, Vijay Lakshmi, which one? Question number 12. See, in question number 12, it was asked to calculate the primary voltage. So we know that primary voltage by current is equal to the trans ratio. So just put the basic formula. So if you don't have any doubt, you can leave, and I will drop the class.
Sir, excuse me, sir.
Yes.
So this is Salakshi. So 12th question, V1 by V2 will be equal to N1 by N2, sir.
Yeah, definitely.
So you are calculating V1. So how come this answer 387.87, sir?
Is it not coming? You calculate it in calculator.
Sir, actually V1 by V2 equal to N1 by N2, sir.
Into I2 by R2. Because
Oh,
this is, in this case, we have said, see, this is the formula.
okay, sir.
In this case, we have our tertiary and secondary winding like this. So we
Okay,
can't
sir.
write it in the format where there is a primary and secondary. We can write Vp by Vs equal to N1 by N2, right? But here, along with that, we have to calculate the voltage of this. So Vp by Vs can be either this one, can be either this one. So we can write the formula like Vp by Vs as I2R2 or either I3R3. But whenever you're taking I3R3, then the trans ratio should be N1 by N3. Okay, but the basic formula is V1 by V2 is equal to N1 by N. I'm just calculate the value of V2. So that will be reversed, right? So you're asking that will be N2 by N1 into V2.
Okay, sir. Thank
Right?
you, sir. Yes, sir.
Anything else? Those who left here, that will be shared with you all. And in the next class, I will also share it in the slide. Okay. Okay, fine. While sharing the slide, I will add the YouTube channel where you can find the video. Okay. Salaparama Babu, don't have any doubt. John, Likhita, Patiwala Tejaswini. If you don't have any doubt, you can all leave. So all okay. Good night, everyone.